Inductive reasoning and conjecture. Is reasoning that uses a number of specific examples to arrive at a conclusion. Conjecture is that conclusion you just came to using inductive reasoning. What you're going to find in this section is you're going to be doing a lot of things that you do every day, but you don't know you're using inductive reasoning. The most common kind of reasoning there is. Basically, we make decisions usually based on patterns we see, things that happen to us, which we would consider examples, wouldn't we? Everyone agree with that? You know, Emily Carey not here? You know, that's what inductive reasoning is. It's the reasoning we're all honestly used to using. That's just the name of it. And it's not always accurate. If for the first 10 days of class, when you came into class, I had a pair of glasses on, then the 11th, you know, you might make the conjecture that what? Coach Stump's going to wear glasses every day. But then you came in on the 11th and my contacts came in. I was wearing contacts. You see what I mean? It's not a foolproof way of reasoning, but, you know, it's a solid one. Okay? Bring us to our other definition for today. A specific example that proves a conjecture to be false. Bryce, when we're done with notes, remember to come get this from me, okay? Well, those 10 days that I went to school and had a pair of glasses on, right? Those were an example of your conjecture being what? True or false? False. No, the 10 days I went to school with a pair of glasses on. Because remember, I said my conjecture was that Coach Stump's going to wear glasses every day, right? So for those 10 days that I wore a pair of glasses, that was an example of the conjecture being what? True. Okay. That 11th day, when I didn't wear a pair of glasses, no matter why I didn't, it could have been because I left them at home, right? Was called a counterexample. It was an example of my conjecture being, I mean, let's face it, guys. I mean, a counterexample is basically anytime you were talking with a friend, he said, remember that instance, right? And you're proving someone wrong. It's what a counterexample is, but it's just important to realize it's a specific. So your counterexample, if that was the 10th day, I don't know what day, I mean, maybe August 26th, right, would be a specific example of that being wrong. A conjecture that all dogs have brown eyes. A lot of examples for that. My dog, for instance, I have a French bulldog. He's got brown eyes. Can anybody think of an example of a counterexample of that? Yes.
Siberian Husky.
Siberian Huskies have blue eyes, don't they? That's the thing. You can't just say a dog with blue eyes. You understand what I'm saying? That's not a counterexample. A counterexample is a specific, and that's why I wrote that in there, specific example of that not happening, a Siberian Husky. Or let's say your dog had blue eyes and his name was Johnny and he's a mutt. That's okay. Johnny has blue eyes. My dog Johnny, who's a mix between this and this, has blue eyes, right? Or one blue and one brown eye. It has to be a specific example. It's not so easy as saying, all people are taller than 5'7". Your counterexample can't be someone shorter than 5'7". Does that make sense? It needs to be a specific example because that's what it is. It's a counterexample. So it's a specific example. Does it make sense? Because sometimes people yeah, you're right. That would be the counter, where the counterexample is going to be, but it needs to be a specific example. Okay. All right. Now, you guys, we're going to do some problems that what I'm going to do is I've decided that I'm going to start posting things like this. This is really a part of your notes. But if we will pay attention, because usually I've had workbooks to hand out to you guys. I don't, we're past our 5 years where they have to send me more. Okay? I don't mind just doing these up on the board and talking about them in our notes, taking a video of it, and then posting this to the event for that day. Because now you've got it to where you can refer to it, right? You can download that PDF if you want to where you can get it offline, whatever it may be. But I also don't want, because I'm not making you write it down, that we fall asleep, does that make sense? This is part of the notes. And you may want to write your own notes. Remember to do this. You know what I mean? Whatever you want to do, but and don't be surprised if I start calling on you individually when I get better attuned to the names, because to try to keep you awake or things like this. Okay. Right here it says, write a conjecture that describes the pattern in each sequence. Then use your conjecture to find the next item of the sequence. So first thing we do, we've got to write a conjecture. Describe what we think is happening. Okay. And then we're going to write the next term in the sequence. You're going to have it's important that you read directions. You're going to have different types of problems. Some problems say, just give me the next 3 terms in the sequence.
Some are going to ask you to write a conjecture. Conjecture is words. Okay? Every one of your answers will probably be a little bit different just about. That doesn't mean they're all wrong. Don't freak out because you're in math class. I'm asking you to describe something. It's no different than an English class when I ask you to read a passage and describe what you read. Same thing here. It's okay to not talk math perfectly mathematically. Because guess what? Your 10th, 9th, 11th graders, you're not supposed to be able to do that right now. Just do your best and try. But understand, on problems that they ask you to write a conjecture, when I'm grading these and I go through and I kind of make notes about which problems are what and what to look for when I'm grading your stuff, you're not writing a conjecture. That's going to be a lot taken off. You're better off writing something that you may think sounds stupid, but is the best job of describing what you read than writing nothing. Okay, -5, +10, -20, +40. Well, sometimes it's better to look at the numbers and then look at the signs. If you were just looking at the numbers, what does it seem like you're doing from here to here? Multiply by 2. I hate using that sign, so we're going to say times 2. To get from here to here, I still multiplied by what? But the problem is that wouldn't work for the signs, would it? Because if I multiply by a +2, this should be a -10. That would be a negative what? 20. This would be a negative what? So that doesn't work. But like you said, if I multiplied by a -2, does that work every time? So my conjecture is, how could I describe that? It's not so terrible, is it? What's the next term in our sequence? I just do your own instructions. Multiply the number by -2. What's our last number? Multiply by -2 is a negative what? Not too bad, is it? How about this one? Okay, so our conjecture would be multiply the previous one by 10, and we just would do that. Okay. I'll skip that one since it's a little easier. How about this one? No, number 3. If you guys really, this is where knowing fractions is better. If you think about it, 5/5 plus 1/5 is what? 6/5 plus 1/5 is what? So on and so on, right? So our conjecture would be to what? Add 1/5 to each number. Next term in the sequence would be 9/5. I would just plot out what you have here. Like I said, make a conjecture. Okay, A is -1, down 1. B is right 2, up 2. And C is to the right 4. Well, that wouldn't quite work, would it? Well, they make a straight line, don't they? So this is a linear equation. What's your slope? So you could describe this as a pattern that increases with a slope of 1/1. And guess what? That's not really right. But I'm kind of trying to do an example here of, you know, a way to describe it in what you see. I think that's a great job if you wrote that. Probably they want you to be more specific. You could say, and doubling. See, because we added 3 to that. See, from here to here, we added 3, right? But from here to here, we added what? So I don't know if there's a mathematical that probably what they might be wanting, what the book might say is points along the line. If you were to graph this line, it'd be y is equal to x. Points along the line, y is equal to x. Okay? But I think this would be great. Okay? I don't want you to fret over. I want you just to try to see what's happening. Just describe it. Okay? I promise you, that's about as bad a way of, that's not a perfect way to describe that. Okay? Geometric relationship. Angle 1 and angle 2 form right angles. My conjecture, what have we learned about, what do you think they want you to stay here? What have we learned about, no. 1 and angle 2 form a right angle. I think what they're saying here is that if you put 1 together with angle 2, it makes a right angle. So basically, when you what? The measure of angle 1 plus what? Equals what? That could be a conjecture. Or you could say angle 1 and angle 2 are, what's the word? There we go. I think either one of those would be a great answer. I mean, if you were to write together, they're complementary or something like that. Use your own words. Yeah. Oh, depending on if it asks you to make a conjecture, conjecture is words, right? Here, my conjecture here, they're vertical angles, right? What do we know about vertical angles? So angle ABC is congruent to angle what? See, this is a lot of what geometry is trying to teach you. Okay, I'm going to tell you this geometric fact. You tell me what it means. It means that they're congruent, doesn't it? It's like I gave you this, and I'm giving what the vertical angle theorem says, that they have to be what? Congruent. Because isn't that what being vertical angles means? That those two have to be what? Congruent. What if you were to write, then they're the same measure? Would I think that'd be a good answer? Yeah. I think it'd be a great answer. Is it what exactly is going to be in the book? No. But we're making an effort, okay? Okay, here they're going to set after it's true or false and then give a counterexample. Guys, on your homework, it is imperative that you give the counterexample. I am supposed to state whether this is true or false. And guess what, guys? A lot of times you're going to make mistakes on this, and that's okay. If points A, B, and C are collinear, then AB plus BC is equal to AC. True or false? Huh? I think that's true. Why do you think that is? What do you think's key there? Collinear. Well, but you know what? It's actually false. Can anybody tell me the counterexample? All you have to do is think of one. True, and you know what I'm going to write here? Most of the time. But let's say 99 out of 100 times that's true. If there's one time out of 100 that it's not, it's false. If you'll remember, what does it mean here? What's missing in this statement? Anybody? It's okay if you don't see. Can you draw things to where this wouldn't be the case? Whatever you have, think of it this way. You have a line, all three are collinear. Can you put the letters to where this would not be true? Basically, if C was in the middle, right? That would mean A was here and B was here. Would it make sense that AB plus BC equals AC? There's no way, right? Because AB is what? The bigger one here, isn't it? All of our minds just jumped to B was in the middle when I talked about it, wasn't it? But did I ever say B was in between A and C? Did I ever say that? I didn't, did I? You guys get the point I'm making here? This works if what? B was here and A and C were here, right? Now it works. That's an example. But all you have to do is put C here or put what? A there. So in words, your counterexample would be A or you could just say A being in between C and B. Wouldn't that be a counterexample? Does everyone agree? Like I said, I am going to post this. You guys see the difference there? See why that's a counterexample? You want to jump to the conclusion, oh yeah, that's true. That makes complete sense. But remember, if you can find one time that it's false, it's not true. You understand what I'm saying? Because when we say this is true, I'm saying it happens all the time like that. And this is one of the harder chapters, I will say, because of the, how it makes you think, and we'll be doing proofs at the second part. Okay. It says R and T are supplementary. So they're saying measure of angle R plus the measure of angle S is equal to what? And R and T are supplementary. The measure of angle R plus the measure of angle T is equal to 180. Then the measure of angle T plus the measure of angle S are congruent. Is this true or always true or not? What do you think? Okay, let's say you're confused right here. And it's understandable. Start picking some values. What if R was 60 degrees? What would S be? And what would T be? What would S have to be? 120? What would T have to be? Okay. Let's make it 90 or 95. Well, what would this one have to be? What would this one have to be? Right? Because they have to both equal 180, right? So you can kind of work these out in your head, can't you? Let's pick another one. Let's make it 100. What would this have to be? What would this have to be? Are we seeing a pattern here? Are S and T always going to be what's left out of 180? And in each case, our R's are going to be the same, aren't they? So what do you think about this? True or false? Can you think of an example when that would ever not happen? No, huh? Any questions? Does that make sense? You see the type of problems we're going to have here, right? Some like these are going to seem, I'm not a big fan of this, but ABCD is a parallelogram. Look up in the glossary and see what a parallelogram is. Your conjecture would be opposite sides are parallel. Okay? This one right here is a pretty good one. ST and U are collinear. So I've got a line here. I've got ST and U. ST is equal to TU. And they're saying that T has to be the midpoint. Think that's true or false? Midpoint of SU. It is true if S and U are your endpoints and T is between them. But did they say that T is between them? So S could be right here. Then this could be U and this could be T, couldn't it? And these could still, couldn't they? You guys understand what I'm saying? If they just said T is between S and U, that would have been enough. Yes, it has to be the midpoint. But because they didn't say that, I could put S in between and I could still have the same situation, couldn't I? But no, this wouldn't work either. What am I saying? Because right there, TU is not equal to them. But it never says that I know it's true if that's the case, right? Actually, this is true, isn't it? What do you guys think? Think it through. I've got a point T, and S and U are the same distance from them, right? I could do it like this, couldn't I? And that was S and that was U, but the problem is then they wouldn't be what? So actually, I think this is what? True. It's okay to make mistakes on this. I do it every year because I think part of a better job of us learning this is to kind of walk through it and see if you can think of any instances where it doesn't work. And the biggest thing about this is you can't be afraid to be wrong. Does that make sense? You know how we're all afraid to put the wrong answer in on our homework when we're doing stuff? This kind of stuff, this is logic. You're going to make a mistake. You're going to say, well, there's no way that happened. But then the person next to you might say, oh, yeah, remember, what about this? Doesn't mean you're dumb. Just means you're trying to work through it. You're trying to think. That's what this section we're trying to do is reason through things. So my big thing is I want you to try. Make sense? A lot of people just give up on this and don't try these problems. I want you to make mistakes. I want you to do what I just did. Make a mistake and then say to myself, wait a second. Because that was the first thing that popped into my mind. I could do that. Then I looked at it, made a picture. Wait a second, that wouldn't work, would it? Right? And so we came to the conclusion that it would, or that it's true. Okay. All right. What does and this is one of those sections you're going to have to be pretty exact when you write the problems. Unfortunately, this chapter is going to be a lot of writing. You're just going to have to deal with that. What does the assignment say in Google? 14 to what? And then what? Write problems, draw figures, show all steps, and work. Now, I want you to realize something. I could have made that a lot harder and a lot longer of an assignment. I did that because I do want the problems written down word for word. Okay? I want when I ask you to describe something, I want you to describe it. Okay? I mean, look at that. I didn't give you the first 6 problems. Then I took 3 of them off. And then I took, 13 of them off? That's only like 21 problems. That's because I expect you to write out the problem, not the directions. I don't need you to write a conjecture that describes a pattern sequence, blah, blah, blah. I need the problem written out and I need work shown. If they're asking, I need it to be big enough where I can read it on your paper. I need your figures to be big enough where I can read them on your paper. Does everybody understand that? I can't say this enough. If we're going to do things with just answers, I'll give you 40 problems. How would that be? No, because then that'll hurt the ones that are actually doing it because these problems may take a little bit. Everybody got that? Okay, another thing. These are due Wednesday at the end of the hour. We will do 2-1 today. We will do 2-2 tomorrow. Then Wednesday, you will have a work day to grade and correct, and your assignments are due then at the end of the hour. If you need to grade a couple that night, I'm sure if you come and talk to me, I might be okay with you turning it in Thursday at the first of the hour. But I've gone slowly through chapter 1 and telling you what I expect as far as homework. Any questions?